has a DC coupled system. What does that mean? He has his solar panels. He goes to a solar charger. He charges batteries. Those batteries then, their output goes through a battery inverter. He creates an AC waveform, and he has a 120 volt extension cord, a 15 amp cord, that he runs 60 or 70 feet, and he plugs it into an outlet in his van. And that works. And that works up to the capacity of that extension cord. Right? So he's got 15 amps at 120 volts, but by the time he gets to the RV, he's probably lost, I don't know, 5% of the voltage. What we want to do is, with that system that he has, he can't run his air conditioner. He has 2 air conditioners in his RV. He can't even run one, because that air conditioner alone will take 20 amps, and he's got a 15 amp receptacle. He may be able to pull it off, but don't turn on anything else in the RV.
And I have for like 15 minutes.
Don't plug in your tea kettle. Don't turn on the television. Don't let your converter charge your batteries, because it's going to draw power. Don't. So he's got all these restrictions, so he spends his whole life managing his loads at this, maybe a 10 amp circuit at 120 volts. Like, he lives that way.
So what are we trying to do?
This is Sonny Bishop, by the way, with your back to the camera. He's shy.
Just trying to.
He's shy. So what we're going to do is we're going to say, what would a system look like if it provided power to the receptacle that was designed for the RV? Well, the receptacle that you have for the RV right now is a 30 amp single pole 120 volt connector. Well, that's twice the power that he has with the 15 amp extension cord. There's already an outlet there wired into this load center. So this load center feeds an outlet for his RV that he can plug a 30 amp plug into. It goes directly into the RV, and the RV runs the way it was intended to run, with a 30 amp service.
Which is exactly what the other RV, Brian's RV that Debbie's living in, is doing. That's just connected. The 30 amp is connected to here, and she's drawing from it.
I don't want to make things too complicated. His RV can actually take a 50 amp 240 volt service, but we're not
even
gonna
thinking
do
of
that
that.
at this moment in time. We're talking about 120 volts, 30 amps. So what I need is a box. What we need to solve this problem is a box that will provide 30 amps at 120 volts reliably. So then I stop and think, where are the places that I can get this power from? Well, I can get it from solar panels. And we get that. We get solar panels right now producing energy that the Bishop family owns, that go through this inverter. It produces AC power. This AC power goes into this distribution system, this load center, which your RV are on. And quite frankly, right now you're using power from this inverter that belongs to the Bishops, that's going to your RV. And how do I know that? Because we've unplugged all the solar connections to his RV, and we're running a test case for 1 week, so we see how much energy he uses,
Which we just started
when
today.
he's plugged into a 30 amp circuit.
And that won't give you much, because this is not cooling season, and he doesn't have.
Right.
That's correct.
Right. So we don't
But
even need all
What
this.
we're going to do is we're going to see, without him playing games, like he just turns on the washing machine, the air conditioner will run for a short period of time.
Okay.
He's the stove, he runs his stove. His fridge isn't going to be running on propane. His fridge will be running on electricity. We're going to get a good idea, except for the peak loads, like you said, in the summertime with the air conditioner. We're going to be able to see in this week how much energy does he use.
If I was living like a normal American.
If he was living like a normal outbacker in an RV, because he's a long ways away from a normal American, because normal Americans live in houses that use 8 to 16 to 24,000 kilowatt hours a year, and he's using 1,000 kilowatt hours a year, so he's not a normal guy. But we love him dearly. We do love TH, sorry, TH. So
Somebody has to sacrifice.
The only thing I understood is that he's not normal.
not normal. Got that. So we're going to build a box that does a whole bunch of things, and let's start with one thing that's dramatically different than today. When the grid goes down today, all these solar inverters shut off. In fact, the Bishops understand that. By law, they have to shut off their grid-tied inverters. They can't produce power anymore. But the Bishops, they have a plan to put a fossil fuel generator that will back up their essential load. So they're nice and cozy and life is good.
As long as there's fuel.
as long as there's fuel. Now I've taken TH off any solar systems right now, except this solar system, which won't be working if the grid goes down. But what I'm going to do is our magic box that we're going to install here is going to isolate this entire system from the grid. It's going to open a switch called a transfer switch. It's going to isolate us from the grid when the grid goes down. Then the magic box is going to send a reference voltage waveform. It's going to look to the PV inverter, this inverter, like the grid came back on. This inverter is then going to start up. It would normally be off, but we're actually going to start this inverter, and it's going to start sending power into this load center, which is going to send power to you. It's going to send power to my magic box, which is going to charge the batteries that will be sitting right here. We're not buying new batteries. We're going to use the same batteries that TH has. We're going to wire them in a safer circuit. They're going to be safer because we're going to run a 48 volt system instead of a 12 volt system. And all the wiring is going to be right here. Okay. This magic box also has a capability for you to connect a generator to it. So if you want to use your nuclear powered, hydrogen powered, waste gas powered generator, we can hook that into the magic box. So the magic box can take battery power, it can take utility power, it can take solar energy power, or it can take a generator power.
Mm-hmm.
So your power problems go away. You'll have 30 amp power, not 15 amp power. You can run anything that you could run on a 30 amp circuit. So whatever your RV cable will deliver, you're capable of using. And you're going to experiment this week to see how you can manage your loads, see if that's what you want.
Mm-hmm.
Once you do that for a week, we're going to understand how much energy we have to generate in PV when the grid is on.
Mm-hmm.
And instead of building a little rack over here, which is where the homeowner doesn't want the rack anyway, because this gentleman, Sonny Bishop's wife, Mary Ann, she doesn't want the rack there. So
She
when I
wants to move the
explained her
fence.
We're going to put a solar panels there. She kind of accepted it, but she didn't smile and give me my normal hug. So I knew that wasn't something she really wanted to do. So what we're going to do is we're going to wait until they determine where they want the fence to go. And when I know where you want the fence to go, we're going to put posts in just like those posts. We're going to take the solar modules that you have, we're going to install them, and they're going to feed power into the Bishop's inverter. So your power isn't going to go through a DC coupled system. Your power is now going through the AC coupled system.
Right.
And it's going to go to the inverter. And now any surplus power that you used to make on the DC coupled system that's made on the AC coupled system is available to export to the grid.
Right.
So Sonny's going to like you now because any surplus power that you generate from your system,
He gets
gonna
the
get
credit
for.
Right.
And he's not going to be so upset with you when you use that surge, that big pipe of power for short periods of time.
Because I've all more than made up for it by what I
produced.
produced.
Offset the power on his bill
Right.
for the power that you do use.
You see what he's
Now,
saying?
That's
Yeah, what are the panels you're gonna use?
My panels.
We're using his panels. They'll go on the post that you tell us
Yeah.
where to put them, and we're going to hook them into your
Are
inverter.
his panels okay?
His panels are okay.
Okay.
TH has little panels. TH has 100 watt panels. Sonny has 390 watt panels. Let's call them
He's
400.
bigger than
for
me.
fun.
You're bigger than I.
So TH has 100.
Me just
you
little
have
guys.
400. So 4 of Sonny Bishop's panels equals 16 of your panels.
Right. But many
So-
hands make light work.
We're going to put 4 of your panels on every post. We're going to need 4 new posts.
Yeah.
So we need the Bishop family to tell us where to put 4 new posts.
Yeah.
And then the power is all going to come into this inverter. And this inverter is 97% efficient.
You know, I really don't know what my wife wants. She wants really me to get rid of the animals, and she takes over the whole place.
Oh no, she loves those animals.
No, she doesn't.
No?
No.
I saw her hugging them.
She asks me every day, "You getting rid of that bull, aren't you?"
Oh, the bull.
Well, the heifer goes too, she said.
But she wants to get micro livestock in their place. Little cows. Kid-friendly cows. She's
Don't
thinking
they
of the
grow into
kids.
big ones?
No.
they
There's,
got miniatures.
Oh, they got toy cows now?
yeah.
She wants to take that, continue that fence all the way down to there.
I've heard different versions, so I'm not too sure, Sonny, where we're going. And so until we
I
know
don't
where we're
either.
going,
Well, I gotta get posts.
there's
this
no
week,
sense in
so-
digging holes because we already dug 3 holes already. Dug,
Yeah.
not dig, dug
Digged?
3 holes. We dug 3 holes and we're gonna take those posts out because they're in the wrong place. So we don't want to do any more of that. But
What size posts you want? The same size?
no, whatever size you want for your fence, that's what we need. But I got to go up 8 feet, so it's got to be big enough to go 8 feet. So I'm thinking we're going to
Well,
use
you
the
gotta
same
put
posts I
something in
use.
the ground, so you gotta have at least.
I'm going to use the same
11
post.
to-
I'm going to use the same post we use for your solar panels. Right? I need 4 more of those 8 by, or those are
They
6
gotta
by
be-
6s, 6 by 6 posts,
Yeah, but they gotta be what, at least
12
foot.
footers. They're 12 footers. They're 4 feet in the ground and 8 feet above it. Roughly, I've got a little more than 4 feet in the ground. Okay, so we haven't finished with the magic box. Is it really that magic? No, it's not. Am I inventing the wheel? No, I'm not. Last year, the state of California came out with a UL requirement for all new inverters, and it was called UL 1741-SA. UL 1741-SA says that this inverter has to be able to be controlled by an external source through frequency shifts. So that rule came from the fact that the utilities want to be able to regulate customers' inverter output in the future. So this inverter, if I had bought it 6 months earlier, we couldn't even have this discussion. But since this is state of the art, it meets that requirement, by the way, which I don't like.
Mm-hmm.
But we're going to leverage the capability of this new inverter. It's going to allow us to do what I just described. So our magic box is going to be able to limit the output of that power when the grid is down, because I don't want it sending too much power to you, because once your batteries are fully charged
Mm-hmm.
and once it's satisfied all the loads in your RV, I can't export power anymore because the grid is down.
Yeah.
So I would create an unsafe condition because that power has to go somewhere. But because of UL 1741-SA, our magic box, which I'm going to give a proper name to in a minute, can regulate the output of that inverter through what's called a frequency shift. I'm not going to go into the details, just trust me, it can do it. So now I have a safe system that gives you the power that you need. The energy you use is the energy you use. So whatever energy you use, you got to put enough solar panels up to make it.
Right.
So that's your job. I'm going to give you a system that allows you to do that.
But it's an Internet of Things. We can monitor, Sonny, how much power this entire area is using or how much just we're using. And then we can make sure that with my panels, we exceed or keep it the same, right? So we're never drawing off of you.
Right. In fact, the meter that we're going to use to do that measurement is sitting right in here. And we bought the meter because the property owner, Mr. Bishop here, wanted to know how much energy was being consumed in this little box and the RVs and the greenhouse and everything else. But when we first connected it, what it was doing is it was reporting what this panel was doing on the website for the entire solar energy system on the property, and it was confusing all the numbers. So we're going to solve that problem by we utilize the meter. That meter is going to provide output to the magic box. And that magic box then is going to be able to give Sonny exactly what he wanted to know, and it's going to give you what you want to know. And on top of all of that, the magic box is going to have a control. So there's going to be a little display in it, and it's going to show all the energy flows, just like you have on your SolarEdge system, into the box and out of the box. So it's going to show how much energy is going to the RVs. It's going to show how much energy is coming from the PV inverter into the magic box. It's going to show, is there a flow of energy out to the utility or from the utility? So it's going to be an island, if you will, from which we're going to measure all the power flows, and we're going to put them in a display so you can see it. So you'll be able to go here, there'll be a little TV screen, you'll be able to look at it and know exactly what this entire system is doing.
Mm-hmm.
Now,
Your students will eat that up.
Yeah.
how much
Exciting.
is this going to
It'd
cost?
be like a microgrid within a
It's going to
microgrid.
cost triple what we would have done before. But you're going to have a system that's going to last 10 years, not one, like the Chinese solar inverters that we're buying and the Chinese charge controllers. Instead of having a 1-year warranty, we're going to have a 10-year warranty. We're going to have a robust piece of equipment. We're going to have a safer system that has more flexibility, can be expanded in the future to more capacity. In fact, this system will be able to be expanded so that we can back up all the loads in this panel. Not initially, but we will be able to expand all the loads. So that means all the RVs, when the power goes out, could have backup power. The fish tanks can have backup power. The hydroponics can have backup power. So anything that's fed off of this, even Sonny's kids, if they wanted to, highly recommend against it, can go and turn the lights on in the middle of the night when the power is off and play tennis. Okay? Let's not do
They don't
that.
do it in the middle of the night. But
Let's not do
Did it
that.
last night in the evening.
Please,
Yeah.
let's not do that. But it's possible that they could do it. And they could do it in the middle of the night because it's backed up with batteries. But poor TH would be upset because the batteries would burn out in about 2 hours and he would have no lights in his RV. So
well, how do my kids stay in shape?
that's true. I don't know. I don't know.
Hey, if I have to sacrifice for the kids to stay in shape,
They don't play after 10 o'clock. And what they do, they can't do it any time during the week. The
Yeah.
only time they can do it is Friday or Saturday. And like now, this is Saturday, they're in Plant City in the
Playing
tournament.
soccer.
Plant City or Lakeland, yeah.
Yeah,
Playing the
playing
tournament.
soccer.
They won't be back till midnight tonight.
and so I think you're also saying, Mike, that this could be expanded with when battery prices drop and they performance improve. This could be the battery backup
Sure.
for the whole property at some
Sure.
point.
So right now the plan is to take 4 of the 6 batteries you've already purchased.
Yeah.
We haven't. You
Yeah.
have
Yeah.
used my battery meter, and you've looked at the state of health of all those batteries, and we've concluded that there's enough life left in those batteries that we can put them in series, create a 48-volt system, which is 1/4 the current we had in the old parallel coupled battery configuration. We had 6 batteries in parallel, which would be over 1,000 amps short circuit, which was dangerous. Now we're going to have 48 volts, which is a common voltage configuration for off-grid systems. We can use much smaller wires. There's going to be much smaller, lower currents. And so all around, it's going to be a better system. All the components are going to be in one location. Battery, magic box, load center, disconnect switches, PV inverter. Everything is right here.
Where do they feed? That box? That smart box you're putting up?
Well, let me go through how this is connected now. Right now, this is the power coming from the house in this box. We'll take panels out to this breaker into this bus. And right now you're producing, because you look at your Solar Edge
Yeah.
display, right now you're producing more energy than he could possibly be using in the RV. Okay, you're producing more energy than the RV's using, Debbie's RV's using, the greenhouse is using. There's no way they're using 3 kilowatts. So what's happening right now, the electricity is going from here back to your house, and you're using it to run the lights in your house, and anything that's left over is running something else on the property or being exported to the grid. So that's happening right now, and that's the way it should be because you bought it, and it wasn't cheap. It was expensive.
Yeah.
I think you paid $2.60 a watt. I don't mind saying that because market price is about $3. So you got a deal, and you got the best
How much did
possible
we pay
system
for
you
it?
could buy.
She would never tell me.
$2.60 a
No, I
watt
mean,
times
bottom line.
you have, what do you got? You got 48 panels and 9 and 10. I think you have 11.4, about a 20 kilowatt system at 260. So what's 20 times 2.6? $52,000. Okay, but then you got a lot of other things. You built the building, you built the carport, you built the
think my battery's
pavilion,
Yeah, she
Good.
told me the whole
you
thing.
built these load
was about
centers.
half of that.
It was the PV system itself was about half, right? Roughly half.
But I meant for the whole thing. She
The whole
told- I said,
thing
"How
was
much you talk
it was
about?"
over
She said-
100 grand.
She told me it was over 50.
She was then just talking about the solar.
The solar
No,
system.
she-
Did she
Anyway,
tell you the whole
she
thing?
knows I don't.
the whole thing was, you paid about $12 a square foot for the carport. It's 30 by 40, and you paid about $12 a square foot for the pavilion. It's 50 by 40. So you can do the math.
Yeah. Well, I just wanted to know because
On
It's a lot of money.
right after Valentine's Day.
I'm the only guy, and I received the checks, and I'm the guy that's saying it's a lot of money because I'm used to building these systems. We've designed hundreds of these systems, and this was a big system for a residential property, one of the biggest.